Well, hi there, boys and girls. Today we're going to talk about reference angles. I want you to get an idea of what they are and how to draw them, and then we're going to do an example at the end where we use a reference angle to find our 6 trig functions. So we've got this definition, and there's some important things about this definition. Let me go over here to, let's do blue. First of all, it has to be positive. Your reference angle must be positive and must be acute, formed by the x-axis and the terminal side of the angle. So let's refresh over some things. I've got an angle drawn in quadrant 1 and one over here in quadrant 3. This is the terminal side of the angle. We had rotated a certain amount. That's the terminal side of the angle. And the x-axis is right here. Here's the x-axis. So the reference angle is the angle between the terminal side and the x-axis. So this would be the reference angle. Let's go take a look at this other one I drew in quadrant 3. It's in between the terminal side and the x-axis. So I've rotated all the way around over here, past 180, but before 270. And here is my terminal side. My x-axis is right here. The angle that is between the terminal side and your x-axis, that is your reference angle. Sometimes you can call this theta ref. Reference angle. So let's do some examples. Find the reference angle of the following angles. 50 degrees. So we're going to draw a 50-degree angle, which is going to be somewhere a little bit more than halfway between those two. So we rotate through 50 degrees, and then we have to find the reference angle. Well, here's my terminal side, TS for terminal side. Here's my x-axis. The reference angle is the angle between them. Well, what is that angle? Well, it's 50 degrees. So any angle in quadrant 1 is its own reference angle. So the reference angle, or theta ref, is 50 degrees. Is it positive? Yes. Is it acute? Yes. Is it in between the terminal side and the x-axis? Yes. Well, that's the reference angle. Let's do a second example. What about 220 degrees? Well, if we rotate 220 degrees, we go 90, 180. That's down here, almost halfway between 180 and 270. So I'll just do that. So there's my angle. Back to blue. 220 degrees I've rotated around. We have to find the angle that's in between the terminal side and the x-axis. So I have to figure out what is this angle right here. Now it's not 220 degrees, number one, because that's too big. It's got to be acute. It's got to be positive. So let's just think about this. I have wrapped around 90, 180, 220. How far did I go past the x-axis? You know, this was a 180 degree rotation. We called this whole thing here 220. So how far past 180 did we go? You're going to have to reason your... There are some formulas, but I'm not just going to give them to you. You're going to have to reason your way through this. We've gone 220 degrees. 180 is the x-axis, so you should be able to figure out that this is 40 degrees. And in this case, in quadrant 3, I did my angle minus 180 degrees, gave me my theta ref. So my reference angle is 40 degrees. My answer to this is 40 degrees. Is it positive? Yes. Is it acute? Yes. Is it in between the terminal side and the x-axis? Yes. Therefore, it's my reference angle. Now we're going to switch to radians. We need help with this. We'll do the exact same thing. 7 pi over 4. Let's see if we can draw these in radians. This is 0 radians. This is pi over 2 radians, which you could think about that as 2 pi over 4. This is pi radians, or 4 pi over 4. I'm just drawing them with a common denominator here. This is 3 pi over 2, which is 6 pi over 4. So we get an idea, converting everything to fourths, that 7 pi over 4 is past 6 pi over 4. And by the way, 0 would also be 2 pi, which is also 8 pi over 4. So where is 7 pi over 4? It's halfway between 6 pi over 4 and 8 pi over 4. So our rotation goes all the way around, and it's halfway between those two angles. So let's figure out what our reference angle is. Back to drawing. Let's see here. The whole rotation here, this is rotating 7 pi over 4. I want to find the angle that's in between the terminal side and the x-axis. That will be my reference angle. That's right here. This is my theta ref. So I have to figure out what is that angle. So I've rotated 7 pi over 4. If I would have continued to go all the way around 360 or 2 pi, I would have rotated 8 pi over 4. So how much is left here? You should be able to figure out that that is 1 pi over 4. There's formulas to figure this out, but I don't want to just throw formulas at you. But that is pi over 4 is my theta ref. That is my answer. Now what did I do? In quadrant 4, which I think I had to I had to identify that. It's in quadrant 4. In quadrant 4, to get my reference angle, I did 2 pi minus my angle theta. And because 2 pi is if it's in radians. If we were in degrees, we would have done 360 minus theta. That's going to be your reference angle. All right, let's do this one last example. Find the 6 trig functions if the terminal side passes through the point negative 1, 3. Negative 1, 3 is left 1 and up 3. There is the dot. So I need my terminal side to pass through there. So let's see if I can't make that happen. My terminal side passes through negative 1, 3. And I have to find the 6 trig functions of theta. To do that, you're going to find your reference angle. At least find out where your reference angle is. Let me get back here. I am going to draw an altitude down to the x-axis. Well, I guess we'll scoot our negative 1 over just a little bit. I'm going to draw an altitude down to the x-axis. That's the first thing I'm going to do. And then my terminal side is right here. My x-axis is here. And I'm going to put my theta right there. Now, I don't know what that angle is. If we've gone left 1, this adjacent side is negative 1. If we've gone up 3, the opposite side is 3. Now, wait a minute. Maybe we do know what this is. Well, I don't think so. Because if we do our Pythagorean theorem, we do a squared plus b squared equals c squared. And this really isn't a special angle. It's 1 plus 9 is c squared. So I was thinking maybe it could have been a 30, 60, 90, but it's really not because this hypotenuse is the square root of 10. And that is not a special right triangle. Negative 1, 3 square roots of 10. So I don't know what this angle is. However, I can find the sine of that angle by doing opposite over hypotenuse. 3 divided by the square root of 10. I can find the cosine of that angle by doing adjacent over hypotenuse. I can find the tangent of that angle, which is opposite over adjacent, which is 3 over negative 1. And I'm just going to let me erase that. You only want to put your negative in one place, either out to the side on the top or the bottom, but not all 3 or 2 places like I just did there. So I just scoot the negative out to the side. We can find our other ones by flipping these over. Cosecant of theta would be square root of 10 over 3. Secant of theta would be negative square root of 10 over 1. And the tangent or cotangent of theta would be negative 1/3. So that's it, and that's how we use reference angles, and I will see you guys tomorrow.